Hi everyone, welcome to the Math Spell Book live stream. I'm your host Peter, and basically we are going to do a little bit of, not much. I think we're gonna do a little problem solving, but that's not the thing I had in mind for today. I thought I would just do a little bit of, reading and analyzing, because I sometimes like to look at textbooks sometimes and just basically see, oh, what kind of good ideas can I take from each book and formulate my own ideas from that. So hopefully you guys will don't mind me just book scouring, if I can call it that. Hey Storm, how's it going? What's the best part of your day so far, my friend? 1 + 1 = 2. Yeah, but try to read the paper that proves that. I haven't even looked at that paper, and I think it's over 500 pages. Let's see here. So first off, I will disengage my model, and then I will start the study timer. Depends on what axiom you have. Yeah, true. So let's go over here. The Pinto axioms, it takes a few lines. Oh, I see. Actually, Storm, I'm trying to remember exactly. Are you a graduate student? Or did you already graduate? Because I'm trying to remember exactly, if you're doing research right now. You're doing research, right? Let's move the math chat, maybe here. I think that would be a good place for it, for this stream. I'm in my last year before my PhD in research internship. Oh, okay, nice. Alright, so let's click in here. So oops. Oh, I didn't mean to do that. There we go. Just pages. Oh, Hilbert space. That looks fun. Analysis. I think we should make this a little bit bigger. I already know things about the set. Oh, oops. Maybe I should use my other web browser. I mean, not web browser, my PDF. Let's see if we have it here. Yeah, right here. So open this, please. There we go. So close this. There we go. What level do you have? Oh, I'm just doing math as a hobby. So I am nowhere near your level, Storm. Actually, we can move the math chat right about here. There we go. That makes it a little bit easier. You follow no course in uni? No. Actually, when I was in uni, I didn't take math. I wasn't majoring in math, actually. I was majoring in English literature. I started getting into math and physics when I was in my final semester at university. So yeah, I'm just a latecomer in the math and physics game. So we got the universal set. Probably should write. I don't usually like taking notes, but I feel as if I write stuff down, I will remember them. Even though I probably will, like, end up like rewriting notes over and over again. Usually for me, I just reread stuff over and over again until like it just becomes second memory to me. Nah, I don't think it was a bad thing. It's just that in life sometimes you just don't discover what you truly love doing until like sometimes you just like it falls right into you. So, you know, like even though I didn't like being an English literature major, I just accept the fact that I was like into writing at the time. And then with that, I just accepted the fact that, you know, might as well just do math for fun, you know? Because I think the reason why I didn't do anything involving STEM at the time was because I didn't want to take exams. And English literature just meant that I just wrote papers. So for me, it's like, it was just a way for me to get a bachelor's degree. So I don't regret it. And plus, the university costs money, so. Okay. So, upper bound and lower bound. In maths, if you need to read it, is equal to nothing. You need to write, draw, and think. Yeah. That's true. Math is not a spectator sport. But sometimes I like reading like the stuff about math and then basically like learning like what math, what like the definitions tell you about a certain topic. I think that's the fun part. So you will try to learn everything before PhD, or you have a goal just to learn one thing? I just want to learn enough math for like physics. So I guess the reason why I'm doing like real analysis is because I want to learn enough so I can do functional analysis, because I know that's also another thing that's involved with physics, or the math involving theoretical physics. So like proofwriting, I have no experience with it, so I figured why not just like try and just like try to learn little by little as much as I can. Because for me, I could see myself just doing this as like basically like something that is sort of like whenever I get home, I would probably do like one problem at a time, and if I get bored with it, I just basically do something else, and then I'll probably come back to it when I feel like I'm ready and energized. Unfortunately, I don't have like a note-taking app on my PC. And the other ones usually cost money, so I'm like, no, I don't want to pay like a subscription just to use a note-taking app. I mean, this one I can take notes on, but I would have to scroll around to look through my notes. It's not like page by page, like an actual notebook. Depending on what level you want in physics, maybe you should start a course on logic. Maybe. Like for me, like whenever I just when I just like read up on math or anything, I just usually like read whatever I feel like I have an interest in. Like if I feel like I want to read something about topology, I try to read stuff about topology. If I feel like I want to read stuff on functional analysis, I read stuff on that, just to familiarize myself with it. Even though I don't know anything about the subject or the prerequisites. Smaller than B. What is cool is that I made a course on all of this for some student this year. Oh, nice. That's pretty cool. I'm guessing the student you made it for is an undergrad, right? There are several ways to learn maths. Starting by what you are doing is a good way. Yeah, like for me, I just like sometimes like when I read the definitions, like I find it interesting how like if you know the definitions, you can somehow come up with an idea on how to write a proof. I think that's really cool. Of course, like when it comes to proofwriting techniques, I know I'm not that good at it. So sometimes like there are times when I feel like I have an idea of what to write, but at the same time it's like, oh no, I was thinking the wrong way to think about the proof. But I think that's what every math major has to encounter. You will learn the techniques in time. Yeah. Because actually I've been like reading more on like I've been like mostly like doing small exercises at Khan Academy and stuff, just so that I can basically be more familiar with the basic concepts. Although sometimes when I take notes, like I'm only writing the ones in like the boxes here, but I know that like me just copying them down is not enough. I mean, I've read this definition many times, but sometimes I don't memorize it. Or I don't remember what I've written. Memorize is a bad word for me to use. I hope your book explains the construction of R with grungy sequences and not well, actually I don't know. Let me check. Let's go to the table of contents. Let's see if so the preliminaries, then it goes into real analysis. Yeah, I think they do. Yeah, there is grungy. Sorry if I'm mispronouncing that. Like, how do you pronounce that? It's like Goji? Goji or grungy? No, that's not grungy because there's no R in the C. Hey Don, how's it going? Gochi. Oh, okay. Gochi sequences. Okay. I usually say Goshi. Oh, okay. Yeah, I'm not familiar with that at all, with those. But then again, I haven't done real analysis. But how you doing, Don? And actually, Don, I will give you a shout out because you are also an awesome math streamer as well. So guys, check out Don. Don does math. He sometimes does math. He also does video games too. So he also vibes. And also, he knows a lot more math than me, so if you have a math question, check his content out. I don't know how to write sound. No, it's okay. It's okay. Pronunciation is, like, really hard to write, like, especially if it's a language, that's not your first language. Okay. So, yeah, because, I also don't want to write too much because let's see, because we just wrote bounds right here, upper bound and lower bound, so let's just look over those definitions so we can just be familiar with them. What else this book covers? Got complex analysis. I think they also have functional analysis, right? Yeah, they have functional analysis here. Hilbert space, real. I'm surprised they don't cover. Well, I mean, Hilbert space does have a little bit of but I'm surprised they don't have a little bit of linear algebra in here, or at least proof-based linear algebra. What is this one? Oh, Fourier analysis and differential equations. Yeah, I gotta brush up on those. Partial differential equations. Yeah, the transition from like differential equations to partial differential equations is like a big huge leap, because whenever I look at partial differential equations, I'm like, wow, you guys are just basically taking one or two equations and just like dissecting every bit and piece of it, and I'm like, wow. Because like in differential equations, you're so used to like, oh, you have this non-linear or this linear first order, and you're like, okay, this is how you dissect it, or this is how you solve it. But in partial differential equations, it's like, this is the heat equation. Let's explain how this heat equation works. Let's explain this part or this part and this part, and then suddenly it's like, yeah, we're finally gonna solve it after a couple of sessions. Linear algebra is done before the course in France. Yeah, true. Yeah, the book does a lot. It's meant for like physics students and engineering students. The actual book must be like a phone book. Well, it is 600 pages, so yeah, probably. When a book has wide variety in the subject, it's kind of a red flag. Yeah, I suppose so. I don't doubt you there, because I bought many books that showed a wide variety, but they don't cover as much. I'm just kind of glad that this book actually covers, like, you know, like like does it the typical textbook style where it's like all boxed, and they actually show you visual examples of each thing. You got a closed interval, an open interval. We know what those are. And there's a neighborhood. I actually like the fact they introduced a neighborhood in this book, because I only knew about neighborhoods from like topology. Like, even though I had no idea what the heck they are. Let's see. The least upper bound. B is an element of the real numbers called the least upper bound, or the supremum of S, if B is an upper bound of S and there is no upper bound of S that is smaller than B. Let's see, the lower bound. A is an element of the real numbers and is called the greatest lower bound, or the infinitum. A is a lower bound of S and there is no lower bound of S that is greater than A. Let's see, what do we got? FPR learning purposes. What does that mean? To solve partial differential equation at a higher level, you need to introduce weak derivative and define some ugly set as Sobolev spaces. Interesting. I don't know what that is, but shows you how deep the rabbit hole goes when it comes to math. And the way they explain it is like pretty, I mean, the definitions at least, they're pretty clear. And with the visuals, it actually helps. Usually with me, when I'm in school or like when I'm taking a class, if something is like very complex and abstract, I just learn the techniques on how to do it, but then I'm like, why the heck am I doing this for? It's like you gain the muscle, but then you just don't know exactly why is it that this is important. A good exercise for you to prove the Archimedes property of R. To say it in another way, prove that all X is an element of R, and for all of E greater than 0, there is N in N such that N times E is greater than X. Okay, since you suggested that, I'll probably do that then. Let's see how that works. Okay, so I'll write down the problem so like when chat moves up I won't lose it. So prove the Archimedes property for the real numbers, to say I don't think I have to write that part. To say it another way, prove that. Actually, let's be a little bit more mathy here. All X element of R, and for all E greater than 0, there is n in n such that greater than x. Okay, I have a different take. I learned the big picture first, learned the language along the way. Yeah, it's not really the approach. I do like the Euro simple for like, yeah, it's a very very good choice actually. If Twitch chat actually had what do you call it? If it had like LaTeX, it would be much easier. Okay, so I guess we'll look up what the Archimedes principle is. Do they have it in this book? Let's see if they have it. Nope, I don't think they have it. I don't think they have it. So I think we're gonna have to look at a different source. I do have a real analysis book. Let's see. Let's go into my okay, real advanced calculus. No, actually, I should look up my understanding analysis book. Not the file. Gotta go into my math textbook file. Let's see, understanding analysis. There we go. Hopefully this is the right one I'm thinking of. No, not this one. I think it's elementary analysis. Hey, Sasha, how's it going? What's the best part of your day, my friend? When you look for stuff, go to the index. Rule to know when you write a symbol and the variables cease to exist. At the end of your sentence, but you write cease to exist at the end of your sentence, but if you write instead of a symbol, the variables stay for the rest of the proof. Oh yeah. Elementary analysis. Completeness. So I remember one of these books that just led me to the Archimedes principle. This one doesn't have an index. Here we go. Should have it here. Archimedean property. Let's see. Theorem. is this in the book of completeness? Let's see. Archimedean property. Given any number x is in the real numbers, there exists an n of n that satisfies n is greater than n. Given any number y. Given any number y is greater than 0, there exists an n in n that satisfies 1 over n. Let's see, I think Control F is easier than the index. Probably, yeah. Example, if I write there is x such that I can use x in the following, but if I write then use x, then to use x, I need to say let x the variable defined by the previous property. Oh, hello, Godspeed. This is understanding analysis. I'm just basically just doing book search. I'm just like doing some books, I guess book scavenging. I'm just like looking, reading a little bit, trying to find some connections with ideas. But how are you, Godspeed? What's the best part of your day so far? The property I gave you to the two parts at the same time. So we gotta prove this thing. Yeah, we're doing a little problem that Storm presented to us. Okay, prove that all x in the element of R and for all of E is greater than 0. There is n in n such that n times E is okay. So so I think we'll just start off with let's see, proof. What's the first thing we should write here? Let's see, prove that all of oops. Suppose x is an element or in the real numbers and E is greater than 0. Oops. Greater than 0. Then there is n in natural numbers such that not 0. It's supposed to be x. I am well, Nothing. I didn't go to college today, so I'm just kind of chilling at home. Oh, okay. Just relax, yeah. Has anyone used, Amon analysis book? All 3 books? No, I don't think so. Welcome, welcome in, let me see if I can pronounce your name. Des Indefense? Is it okay if I call you Des? Let's see. When you have a problem with prove that blah 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 and for all blah blah blah, the proof starts always let. Does it matter? Does it matter if it says oppose or let? Because usually, because I think like, because they both sound the same. I don't know. I usually start with suppose because I usually see people write suppose a lot. Then when you want to prove something exists, there is 2 ways: build it or suppose that it does not exist, and find the parallel. Its name mean drawing of children. Suppose works too. Oh, okay. And Riemann manifolds. But in general, introduce a variable, you write let, and suppose is for some property you admit. Oh, okay. So I guess I'll keep that in mind. Okay, do I have to have previous definitions to know this? I mean, to answer this, to prove this? Do I have to have prior definitions to know? That's the question. So E is greater than 0, so we have to prove, so... Now... So E is greater than 0, but that doesn't mean that it could be greater than X. So... how do we start this? Suppose is for contradiction. Oh, okay. Just the definition of up and lower bound. Oh, okay. So let's take a look at what definition we have. Let's see. So if X is you haven't defined what E is, or at least what set it belongs to. So if E is greater than X, then we can define E as an upper bound to the real numbers. it's not epsilon. It's not epsilon, it's E. If E is... Let's see. Lower bound and upper bound. So we're trying to prove that. No, that's not right. X should be greater than or equal to X. So that would mean that E is the least upper bound, right? But yeah, it would be the least upper bound then in that case. Let's see what we got here. Does it come from Lorentz systems? Glad that we have so many scholars in here. Oops. Okay, bring this up. Bring this up. When you want to prove that something exists, there's two ways: build it, or suppose that it does not exist and find the... What is a parallel? Like, what is that? I'll find a problem. Oh, okay. An issue if you prefer. Oh, okay. Like proof by contradiction. I think I have to write as the lower bound. No, wait. So this is... It's greater than or equal to X. Because we want E to be greater than X. Or equal to X. Then E is... Because the thing we're trying to prove is that N times E is greater than x, then E is N. Because the way the definition's set up, let's see, a real number such that if x is... Oh, wait a minute. Because x is supposed to be the thing that we're categorizing here. So... I guess that was a lot of thinking right there. Actually, I'm gonna check what you guys are chatting in the chat. I think there's a way to create manifolds from stability and or instability of a system. So I thought, and I might come from it. The first way. First way better. So interesting how you guys are exchanging ideas off of each other. It's really cool. You guys might make a discovery like might make a discovery in chat and it's like, oh my gosh, congratulations guys, you figured out the secrets of whatever it was you're researching. That would be pretty cool, right? Like one stream, like one of you guys are like just typing something at random and then suddenly like, wait, I got it, and then you start writing stuff on your computer and then you'll be like, yo guys, I discovered this thing, and then you could post it on the Discord and basically I'll just show it to everybody. But then again, you're probably working on your thesis, so it's like, no, you'll know from my paper that I publish. It's just an alarm. Yeah, sorry about that. Other advice before starting writing some proof, just think with your... Are you saying think with your head? Like, think of everything in your head before you start writing? Is that what you mean, Storm? The thing I said is kind of well known thanks to, Samael? Is that like a mathematician? Yeah, Des, I don't like the stuff that you're typing about manifolds and stuff. I was like, oh, that sounds cool. Yeah, I think with proofwriting, I get like a little bit intimidated because I don't know the first thing about proofwriting. A big one. Oh, okay. I see. Yeah, I think like with proofwriting, I get a little intimidated because I'm like, I know I have to know the definitions and I have to use those definitions to create something, but at the same time, I'm like, I think like that's the thing with what every math major faces is that how do I start a proof? And how do I know it's not being redundant? And how do I know that it's not involving scratch work? Because I mean, a proof could be like no more than a couple sentences if you know how to word it right. Because, I mean, actually, like, question for you guys that are doing research, like, how far have you guys gotten to your research? I actually want to know what the progress you guys are making, because I know you guys are working on your PhD thesis, so I wish you luck on like your research, because I want you guys to get your PhDs. That way I can talk to people that actually have their PhDs and like basically get a first-hand like, I guess, witness account of like what was it like for you guys to actually experience going through that process. Yeah, proofwriting is hard. I value more proofs than exercises. Like, what do you mean by that, Des? Do you like just reading papers that people have already proven and just like be inspired by those ideas? Yeah, for me, I just like reading the definitions. Like, for the proofwriting part, I'm like, this is like the ultimate test of actually creating art from like the logic that mathematicians have created. Proof is what is more important in math. Yeah, right. I agree. I agree. I think that's what makes math beautiful, actually, because you just write the proof and it's true forever. If the logic is solid. I'm not doing research. I just happen to like asking a lot of people asking a lot of, I'm guessing, a lot of questions to people. Oh, okay. Proofwriting is never easy. Even papers by field medalists can have pretty poor written proof. Oh, okay. I never knew that. I always thought that they had to be very, very like prim and proper. To learn the definition, the best way is either to build example or to use them in some proof, right? I mean, there is another book I have. It's called The Book of Proof by Richard Hammock. I feel like I probably should start that book, actually, because that book is mainly for like I think that book is more for an introduction to proofwriting. But then again, like, you know, sometimes I wonder if like I'm kind of like jumping the gun when it comes to like learning how to do proofwriting in different ways. Because when I look at proofwriting questions, I get so intimidated because I'm like, oh man, like I don't know where to start. And when I think I have an idea how to start and how to write it, I write too many definitions and the proof just gets so convoluted. Or at least my proof gets so convoluted. Because I'm like, I'm writing definition after definition, but I'm not proving anything. Yeah, unfortunately, there's no, like, I guess, how should I say? There's no easy way to get into proofwriting, I guess. I mean, there are books that basically explain proofwriting in a better way than Rudin. Baby Rudin, I'm so glad that there are actually like math YouTubers that talk about. Well, there's one math YouTuber I watch who basically says like he doesn't like Rudin, and I'm kind of glad that he said that because every math channel that I've seen on YouTube, they always talk about like if you know how to do Rudin's book, Baby Rudin, you basically are just you're gonna be really good at real analysis. And I'm like, oh man, like I tried to read like the first part of Rudin and I was like, I don't know where I'm going with this. What is difficult when you read proof from some other mathematician is that everybody is a bit lazy to write well the proof because it is really long, so they make some sentences with hidden messages. You need to understand it. Okay. Sometimes an example kind of destroys the definition. Right, yeah, because I think like a lot of proof classes, like students would raise their hand and basically say, "Can you show an example, please?" And then the professor's like, "I just showed you an example. Just follow the definition." There's a pretty funny expose by Jean-Pierre Seri on how to write mathematics badly. Yeah, I'm probably like in that camp. Exactly. Sometimes they skip steps in the proofs and you have to really understand what the writer is doing. Right. Yeah, because I like the books that basically are from math professors or mathematicians that basically are like, yeah, I know like a lot of people are not going to understand proofwriting, but I'm not going to make it hard for the reader to actually like follow along. That's why, like, I wonder, is like, what, like, I love math, but at the same time I'm like, is like, do I have the prowess, or at least the ability to write math proofs? Because I know for theoretical physics you have to know a little bit of math proof techniques. You pronounce it, Seire? Is that how you pronounce it? Seire? That's why a big book is kind of bad for self-study. It's self-contained maybe, but for self-study it's not good, right? A sir. Oh, okay. Better, but no. Oh, okay, because like the way you typed it, I read it like as if I was reading Japanese. That's why I said it that way. Because I know the E is like a ser. Right? Okay, right. Yeah, I forgot that there was an accent mark. 少し話します。少しだけど。Yeah, it's been a long time since I've spoken Japanese actually, because like I took it in university, but I started learning it when I was in middle school, just for fun. What did you show? Oh, I gotta turn on. Let's see here, what we got here.
Yeah, I don't want to use this, so maybe I should explain before I really start that I was asked to speak on writing mathematics, and probably with
this. Interesting. Very funny. Very funny.
So,
you are the bird that's overlooking my proofs writing. On that note, a Japanese mathematician won the Abel medal. Oh, what is the Abel medal? Or is that the Fields medal? Or the Nobel, you're saying? Just announced today, I think. Oh, nice.
So let's imagine somebody who really wants to get rid of the theorem he has proved. He wants to publish it, he or she. The sexes are different. He wants to publish it as soon as possible. He doesn't care that he's not read or understood. And he might prefer maybe not to be understood sometimes. That's so what does he do? Well, first he has to choose a title which doesn't give any information at all. So for instance, he can say
11 years ago, wow.
Or and then take either somebody absolutely known so that you don't know what that is, or else say a poor theorem of Euler. I mean, the two things are essentially
Fields medal equal before 40 years, B the best, Apple equals B the best along your career and every age. Oh, okay. I never knew about the Abel medal. Both are best prize to win. Nice. JP Serre is described a technical genius, which is again kind of bad for entering students like me. I tried to read his and was humbled. Nah, that's how I feel whenever like you guys introduce like new ideas to me. I'm humbled to actually being able to be with individuals that are actually able to explain it with such enthusiasm. I mean, even though you guys are typing text.
If you don't know what is AT&T, And FPPH, of course, he made a misprint. You see, he wanted to write FPPH, but putting a misprint in a theorem makes it even harder to understand.
Now he's 99.
For regular,
Wow.
for regular,
He's still going strong. But of course, this was taken like 11 years ago, or maybe even older than that.
About 2 dozen different definitions. So that's okay. So
I'm just gonna save this to my math and physics so I can watch it later.
side of the referee.
I know I'll probably learn a lot from this. So what do we got? Maybe current Sarah is the one who knows the most mathematics on Earth. Oh, okay. That's pretty cool. I mean, like I do know about some mathematicians, but I've never heard of him though. But then again, I'm not in the mathematics field, so I probably won't know the champions that are like in where most mathematicians would know. Like the only I mean, I do know some of them, but like not like mathematicians, but I do know some like theoretical physicists by name. Like basically I've seen them like on like, you know, YouTube as well as like other programs. Like I mean, like a lot of people know about, well, a lot of people that are into physics, they know about Ed Witten, Robert Digraph, I mean like the big names like Brian Greene and like who else, like Alan Guth, Leonard Susskind. Like I only know like the I don't want to say that they're big names in their field, but at the same time they're also not people to scoff at either. I only know like the ones that I think people that are into the hobby side of physics know about. I don't know like the deep like geniuses of the field, like of the fields of whether it be math or physics in general. Like probably the ones that are the best communicators that I am familiar with. He's one of the founders of modern mathematics with Grothendieck. I prefer the style of Grothendieck, very constructive, but his he sins of generalization, which makes it hard to read. But his way of exposing is how anyone would begin to present his research. Huh. So I guess some mathematicians still struggle to basically make their proofs like kind of like nice and readable for people. That's understandable. Okay, before I continue on with the next part of the study session, I will be right back, guys. Just give me a quick second. Alright guys, I'm back. Sorry to keep you guys waiting. And if you're actually tuning into the stream for the first time and you like math and physics, or you just need a productive stream to get you studying, or just getting you to work on the stuff that I guess you've been like procrastinating on, or you feel like it's gonna be hard, you know, drop a follow if you're watching this on Twitch. If you're watching this on YouTube, you know, drop a sub, as well as give a like to the video and comment down in the comments down below if you're watching this on YouTube. Much appreciated. Okay, so let's see what you guys typed up. Let's see, every mathematician write their proof for them and the people who almost already know the answer, so it is difficult for every other mathematician to read proof of the other. You should read Recoiled Similes. There's a translation for free. It's the best math related non-math book I read. Okay. Approach is pretty much being the problem with a lot of abstraction until all difficulty are completely dissolved. His style, that's his style, Rising Sea. Interesting. Okay, so I think right now I think I should like do a little physics now. Like actually do some basic stuff. Because I haven't done physics in a while, so I probably should learn. I should probably like either refresh or like learn a little bit more on both. So let's start the study timer. Because I've been slacking on both subjects. Let's see, we got impulse, momentum, impulse. This one's a lack. I'm just like trying to get through like, cause I'm familiar with certain concepts, I just haven't like done problem solving a lot, so I feel like I have to actually like go through a majority of basic stuff. Okay, thanks for chilling with us, Storm, and thanks for all like the information and the input you've given in the stream. Take care, have a good night or good evening. I've also experienced this, the more general something is, the more context you have. That's good to know. Let's see here. I don't remember impulse that much. I remember momentum. Let's see, a ball A of mass M is made of clay. A ball B is made of 2M and is made of rubber. Both balls are dropped from the same height so that each speed V initial just before contacting the surface below. A ball A sticks to the surface and stops. Ball B bounces back with the speed V initial over 2. The speed of each ball just before and after its collision with the surface is modeled below. Consider the change in momentum of each ball during its collision with the surface. How does the change in momentum of ball B compare to that of ball A? Okay. Okay, Des. Thanks for hanging out with us. Take care of yourself. Happy travels. I'm guessing you're typing be warned, Sascha. Be warned. Recoiled Similes is sometimes a blood bath, especially when he's talking about his previous student. Like, oh, I see. But then you see his interview, very nice and collected person. Let's see. Okay, so the main So the main question is how... Oh, oh, no, I don't want to highlight it. I want to erase it. There we go. Oh. Bye-bye. We don't need that there. Okay. So how does the how does the change in momentum of ball B momentum of B compare to that of ball A? Okay, so let's see here. So the ball bounces back at V1/2, and basically when the ball falls, because one is made out of clay and one's made out of rubber, so one is 2 times the mass, so the momentum of B is 2m. So they both have the same initial. So this is one is for... What was the symbol for kinetic energy? Was it T or... I don't think it's K or K or T. Because I know V is potential. No, T is temperature, I think. So I think it's K. We'll just write K to make it easier. Kinetic energy. And for the kinetic energy of A, it's 1/2 times m, V initial. So well, actually, it should be that to minus 1/2. He is a very nice dude. Got hard feeling with him since he didn't resign with him. People are people. Okay. So now So they're practically the same. Yeah, they look just about the same. I mean, energy is conserved. I mean, it would make sense. So let's see if that works. No. Oh, I'm doing the kinetic energy. What am I doing? It's supposed to be the momentum. That's probably why I was writing like, Yep. Okay. With the momentum, it should be M for P of V, then M so for this is why I always write the questions down, because I'm like, oh wait, I'm not doing the right thing I'm supposed to be doing. So it's 0 minus that. And right here, delta P B, where V forget the 2 on the top. So thinking that they're both equivalent to each other. Is there something I'm missing here? Bounce backs up with the speed of each ball just before and after its collision with the surface. Average force times. Let's see what I'm missing here. Oh. That one was just a guess. I'm just basically seeing what I did wrong here. See, a puck on a horizontal surface with negligible friction. It's pushed to the right by a horizontal force. A sensor was used to measure the puck's momentum every second. Graph of the puck's momentum as a fraction of time below. Okay, during the time interval shown in the graph, which of the following statements is true? Well, if we have the momentum here, so I'm guessing this is 2, 4, 6, 8, 10. Yeah, that seems to be about right. So the approximate, so basically it's a straight line, so it's constant. So it starts out at 2, the momentum is at 2. The distance, let's see, what do we got for the answers? The approximate change in the puck's momentum is 5 kilograms per second. So I'm guessing we got from 2 to 3 then 3, 2. Oh, this is really close. So we're not given easy numbers here. So I don't think the approximate change of the puck's momentum is 5. I think it's a little bit more complex than that. The approximate change in velocity of the puck is 3.2. The net external force acting on the puck is approximately 2.8. So the impulse looks like it says the impulse of it is basically 4 times the time. Because I don't think it's A. I don't think A is like... So it looks like the impulse is basically the force times time. So how much the force is not changing, but how much time is influencing the force. Let's see, the approximate velocity of the puck is the external force acting on it. I feel like these two are part of it, but I think it's because we have like kind of bizarre numbers here. Oh. So these two are the correct ones, but not this one. Let's see why. The impulse delivered to the puck is equal to the puck's change in momentum, and the change in momentum can be found by subtracting the initial momentum. So the momentum is just basically the impulse is just basically the difference of the momentum. Let's see the net external force, so momentum over time, 5 seconds. Okay. So like I'm basically learning a little bit as we go. So at least I have a better idea of what impulse is now. Let's see, a baseball player uses a bat to hit a ball that is initially moving horizontally. So we are given this initial speed. We can erase this part. We don't need this. So the initial speed is 40 40 meters per second. 43 meters per second. And immediately after the bat and ball collision, the ball moving horizontally in the opposite direction. So the final speed is the bat and the ball are in contact for about time of contact 0.0 10 seconds, and the mass of the ball is 0.14 kilograms. Okay, so we write down the question, calculate the magnitude of the average force exerted by the bat on the ball during the hit. Assume the force is horizontal in the horizontal dimension. Enter your answer with two significant figures. Okay. So we know that the summation of the forces is the difference in momentum over the difference in time. So the momentum here is that we have the mass minus the velocity, and then the time is from, so this is time final. Time initial. So I guess we're gonna have to take our trusty calculator. So we have a mass of kilograms, and then velocities, and then divide that by 0. No, actually, wait. Because I remember there's also a direction here, so we have to take that into account. So divide that by no, that doesn't look right. Because it's a negative, I don't think that looks right though. Because if you have 50, yeah, and the difference is 13, and then so Did I miss a decimal point or something? No. Yeah, we got that part. Oh, they treated this as the negative. Because I was thinking about the pitcher like throwing the ball and then basically like hitting the. But why would that make a difference though? So then 14. But why though? The initial velocity. Let's read the question. Maybe I read the question. Initially moving at a speed of immediately the ball. Because I thought the opposite way was basically when the ball hits, that's when basically we put a negative. So if we put a negative sign on front of here, and that minus the initial, then that would be negative. It would be negative. Yeah, so far we are not doing well on this one. Okay, an object with of a constant mass moves horizontally in a straight line. Which of the following graphs of the object's position as a function of time has the magnitude of the object's momentum increasing? So it's going further. This one, basically, as time goes forward, the position is going back to 0. Which of the following graphs of the object's position as a function of time is the magnitude of the object's momentum increasing? So basically momentum is mass times velocity. So in order for the momentum to increase, velocity has to increase. So this graph. Yeah, the momentum would increase in this point. because it's moving at the specific. Because if it starts here and then goes. Oh, this one, yeah, the velocity is going at a constant rate. So maybe this one? No? Why these two? I understand this one, but why this one? The two graphs show the slope, the magnitude. The object's mass is not changing, so if its magnitude of its momentum is increasing, then the velocity. Yeah, I came to that conclusion. Therefore, we need to find the graph for which the magnitude of the slope is increasing. The slope with an increasing magnitude gets steeper over time. So I'm guessing it's just basically going faster to 0. I don't. It's like 0 points, but you know. So now I basically learned, I guess, the hard way of what impulse and momentum are. Like, I know what momentum was, but I forgot what impulse was. But like doing problems involving them, like I guess it gives me a clear, like a better perspective of how to like view them. Of course, like if you're watching this on YouTube, you know, like I will get questions wrong because I'm trying to actually like see where is it that I lack in my thought process of actually seeing what the physical phenomenon is by its intricate parts. So that way, like with problem solving, like I can understand it bit by bit a little bit. Because I think that's why like failing problems is like kind of like a better way of actually like just solidifying the knowledge in my head, along with like clear explanations on why it's that. So let's see. An object's momentum as a function of time is modeled by the graph below. Which of the following graphs represent the net force of the object? I think C. Yeah, because it starts at 0 and it's like right here. At least I got that right. Alright, so let's see here. When ignited, a model rocket exerts a thrust force for a relatively short time. During this time, the thrust varies. Force and time data were collected in a lab for such an engine, and the resulting graph of the engine's thrust force as a function of time is shown. So the thrust force goes high up here, but then it drops within like 0.3 seconds, and then it teeters right around here, so it goes at a constant thrust force. Let's see. An identical engine is then placed into a model rocket, giving the rocket engine system a total mass of 0.2 kilograms. The rocket is suspended long horizontal string as the model below. With the rocket initially at rest. Okay, so we know it's gonna be 0. So let's write down these facts. So we got a rocket that has a mass of 0.2 kilograms and initial speed is 0 meters per second. The engine is ignited and the rocket moves horizontally along the string. Based on the thrust versus time graph above, which of the following is the closest estimate of the rocket's speed and momentum on speed at the moment the engine burns out? Assume that the resistive force is negligible. The mass of the rocket is approximately constant, and the string is long enough for the rocket to move freely during the time the engine is burning. Okay. So we have a force, and the summation of the forces is the difference in momentum and time. So the time when the rocket burns out is 0.3 seconds at the end, and it starts off from rest and it goes, so the force of the thrust goes up to 25 newtons. So we know what time to, so I'm guessing we just multiply delta t. I don't know if it's gonna be that easy, but we can give that a try and see. And now we have to determine the speed. And then, oh yeah, we also should write mass so basically we're just left with the final speed actually. And we already know the mass, so we should write this as and then the speed times mass. Okay, so let's just scroll down here. Okay, so let's just type this in our calculator here. So delta t is 0.3 seconds times the force, which is, and then multiply that together, and then divide that by the mass, which is 2 kilograms, which gives us 37.5 meters per second. Assume that the resistive force is negligible. I'm guessing it's gonna be this one, based on the calculations we just did. Okay. Let's see how they did it. Because even though we got like a rough estimate, like I feel like they were trying to expect us to do perfectly, so I want to see what they did step by step. Yeah, we got the mass here. 8.25. Guess because we got like 7.5 when we did the calculation. It's roughly like 40. Because I want to know what numbers they used. Oh, they actually used the triangle formula for this. I guess it's because like I'm so used to calculus, I basically just do everything like I would rather do it by integrals. Oh, I guess that's it for today's session, guys. I mean, that was fun. We actually got to do a little bit of proof writing and a little bit of physics there, but that was a lot of fun. Now, of course, I did fail on several of the questions, especially involving impulse and momentum, but I think those questions kind of help boost us up for this little tidbit within these questions. So, thank you for joining me today, guys. It was a lot of fun being able to engage with the typical math and physics content with you guys. You know, like if you're watching this on YouTube, for all those that basically gave a sub on YouTube, thank you guys very much. It always like excites me whenever I see like new people join the YouTube channel. In addition, if you are watching this on YouTube, don't forget to drop a like and a comment down below, as well as a sub to the channel. And if you're watching this on Twitch, you know, drop me a follow if you like. And if you feel generous enough, you can also drop me a sub, because we did hit affiliate, so you can sub now if you like, but only if you want to. You don't have to if you don't want to. Yeah, so for all those on Twitch, thank you for joining me today. I'll give you a link to my YouTube channel if you'd like to sub to my YouTube channel to keep up with the VODs as they come out. I always stream from Monday, Tuesday, and Wednesday at the same time, 2 o'clock Eastern Standard Time to 4 o'clock Eastern Standard Time. In addition, if you would like to join our Discord server, you're more than happy to join the Math Spellbook Library Discord server. If you're watching this on YouTube, all the links will be down in the description down below. And it is Wednesday, so if you would like to also check out my gaming channel, my Uncle Talks channel, that will also be in the description down below if you're watching this on YouTube, and it's in the chat if you're watching this on Twitch. So thank you guys for joining me. It was a lot of fun today. So I will see you guys next week, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys next week. So take care, guys. Bye-bye.